All right, so just to let you know, this class will be recorded and placed on a YouTube channel, my YouTube channel, JSM2542, and I'm going to give 5 minutes grace time for folks to arrive in the Zoom room. Again, I'm just learning how to advertise for a class, so this is lesson number 2, equations and word problems tonight, and we'll go over my course as it's set up, workshop model with quiz and classwork problems. So 5 minutes, and then we'll begin. So just as a quick technical note, I was able to successfully log on from my laptop and join the room here as Josh W. And what I'm going to do now is see what happens if I turn video off, if that will hide the screen, and it does on the master screen, so very good. All right. So again, I'm going to wait until 7:05 to start the class. And the classes will be recorded as I go through all 22 lessons here online, and place them on my YouTube channel for free access. The Google form links are active, and I'll leave them active on my Columbia University Drive. For those who are interested, my name is Josh Wiener, and I spent many years as a street performer. And I hadn't completed my college education, and then I decided to take that money and take classes back at college and complete my college degrees. And then I was accepted into Columbia University Teachers College, and again, using street money from juggling and playing the piano, and became a math, got a master's degree from Columbia University Teachers College in math education. I've been working for the past, it will be my 10th year with the Chang Learning Center in Brooklyn, where I'm their math specialist. I mean, I worked in public schools and private schools, and now in my 10th year, this course has been evolving for year after year, and this is the latest, greatest course with as I rewrite it each year for the students and families who live in Brooklyn, New York. So just 1 more minute. I'm going to mute for a good 60 seconds, and then we'll begin tonight's class. Lesson number 2, equations and word problems. Well, again, welcome tonight to JW2542 Tutoring. I am Joshua Wiener, and I present to you my SAT math class here online on Zoom. So welcome. I've been developing this course for tutoring houses in Brooklyn. This course goes for $1,800 to $2,100 per child in private tutoring houses. And please realize that I am accepting donations on Venmo. So if you scan this QR code to pay or go to Joshua Wiener 10 on Venmo, you too can donate. The suggested donation is $50 per lesson. And I will leave the links active for you, as well as the support videos and other materials upon request by email. Again, this is a completely voluntary donation. You do not have to donate to use this free course online, but it does help with my development of the class, and so that I can spend more hours to bring content of this level to you as well. I did have a lot of success last summer, for example. Of 18 students, 5 of them received an average of higher than 700 in the SAT math section, and we had a near perfect score for a couple of those students. So with that in mind, please enjoy this class. I'm going to turn off the video so that I can start this slideshow. Here we go. So tonight is lesson number 2 of the 22 lessons that I will share of the 28 lesson class. And if we go here, you can see that this is the SAT math class as it is still set up for the 2023 year. And as you can see, the math questions on the SAT focus on algebra, geometry, coordinate planes, charts and graphs, probability and statistics, and a few other math topics. They're split into currently 58 questions. Section number 3 is the no calculator section with 25 minutes and 20 questions. And SAT section 4 is also mathematics with 55 minutes and 38 questions, for a total of 58 questions of SAT mathematics. This is lesson number 2, equations and word problems, evaluating equations and word problems of the 22 lessons I will share. And here is the checklist of 28 lessons in its current form that I personally wrote in the year 2020 that was used in tutoring houses and for dozens of students down here in Brooklyn, New York. As you can see, if you look at the 28 core lessons, they're in modular form, starting with about 12 algebra lessons, and then a focus on geometry, Pythagorean theorems, SOHCAHTOA, and then ends with a review of charts and graphs and probability and statistics problems. When you're preparing for a large standardized test, such as the SAT, remember that you have to stay organized, but you can go over the material in this fashion, just like a checklist, so that you too can be organized, reduce anxiety, and perform better on the SAT exam. The other thing that's good to know about the SAT itself, as I mentioned last week, is that SAT math questions are arranged easy to challenge level in both the multiple choice and the grid-in sections. So as you can see here in this coded list of the 20 questions, in light gray, you have the first 15 multiple choice, and in the dark gray, you have the grid-ins. And down here on the third row, here I'll turn on the annotator. Down here in the third row is the level of difficulty of the question, scaled from 1 being easy and 5 being the most difficult. So since the test questions are arranged from easy to hard level of difficulty, a basic strategy is to go through the exam doing the easy level questions. When you reach the challenge level block of 5 questions here, skip it and go to the grid-ins instead, and complete those easy ones, and then check the time remaining and do the remaining questions that are more difficult with the remaining time left over after you reach the 20th question. Similarly, in section 4, there are 30 multiple choice followed by 8 grid-ins. But you can see the clusters of level 1, 2, and 3 questions are the first 20, and most of the level 4 and 5 questions are in the last 10. Similarly with the grid-in, the first half are easy level clustered, and the harder questions are usually in the second half. So of these 58 questions, approximately 37 are easy to mid-level. So by going through the exam and budgeting your time, we found a success rate of over 90% in the last 10 years of getting students above a score of 5 to 600, even students with English language difficulties who are English language learners. So, again, if I were to reiterate, here it is with a color annotation. I've annotated the blocks of questions that are easy level first 5, mid-level, and then the challenge level are here. Easy 10, mid-level next 10, and challenge level are usually the third 10 blocks of questions. So by doing the easy and mid-level questions, and then fast and accurate, and then using the remainder of your time to do the challenge level questions after going through the grid-ins, you can receive a higher score success, because your raw score will be higher because you've completed the questions within the allotted time, and find that you too can boost your score on these standardized tests following this basic strategy. This is the normal curve distribution, and went with large data points such as the SAT, between 1.5 and 2 million data points from students. The mean score is calculated and given a 500 based on the student results on the exam. And since it's normalized, you can see that a score of 1 standard deviation above gets a 600, 2 standard deviations above gets a 700, and 3 standard deviations above receives a perfect 800 score. On the flip side, the lower scores, down to -3 standard deviations, the lowest possible score in the SAT is a 200. But by working with the tutoring house or with tutoring books in an organized fashion with a checklist of topics, you too can make sure that you're on the right half of the normal statistics normal curve and have a score that colleges are interested in addition to your college portfolio. In fact, as a teacher at tutoring houses, I recommend that, yes, if you can achieve a score on the actual SAT above a 500, that's something to add to your college portfolio, that you can sit during a standardized test setting under timed pressure and complete to proficiency in the upper half of the class, upper half of the results. This is very important for colleges when they decide to select students to be part of their college community. So stay organized, work with the tutoring course so that you too can be in the upper half of the normal curve. When we focus on the subtopic, such as tonight, there are some basic algorithms that you too should be familiar with, and formulas. For example, the order of operations, or PEMDAS, you should be familiar with for this lesson. Linear and quadratic word problems are part of algebra. Tonight we'll be focusing on linear. The form of y equals mx plus b, or slope-intercept form, is most common on the questions for the SAT. You should also be familiar with adding or subtracting two linear equations, and that there are systems of shortcuts for many problems that can save you time on SAT questions. Tonight, before we look at this algebra lesson number 2, equations and word problems, let's look at just a few examples as a warm-up so that you too can understand the type of math that's on the SAT. We went over these last week, so if you'd like, and you're watching the recording, you can fast forward these 3 warm-up questions. So here for lesson 2, again, if we have 5x plus 6 equals 10, what is the value of the expression 10x plus 3? Pause the video now if you would like to solve it for yourself. You can see here that this is solvable if you know the system of algebra and you know how to rebalance using the 4 basic math operations. Let's look at 2 shortcuts that work for number 11. For example, the correct answer, hopefully you got, was C. If you did, congratulations, very good. That was the correct response, C11. Student number 1 used the following shortcut. The first thing the student did was they subtracted 6 from both sides and got 5x equals 4. Then, noting that the expression is 10x, they doubled both sides so that that element 10x is now 8. Then, 10x plus 3 must be 8 plus 3, or 11. And the correct answer is C. Student number 2 had a different shortcut. Here, the student looked at the equation and saw 5x and saw the expression had a 10x. So they doubled the entire equation from left to right. 5x becomes 10x, 6 becomes 12, and 10 becomes 20. So now we have 10x plus 12 equals 20. Then, since the expression is 10x plus 3, subtract 9 from both sides. 12 minus 9 is 3, and 20 minus 9 is 11, and you get the same correct answer, C. The next example also shows that if you know how to multi-step with algebra, you also have to know about how to do the same thing with exponents and square roots. Question number 14, we have k is a positive number greater than 0, and x equals 7 in the equation below. What is the value of k? Well, here we are given the value x. So 7 can be placed in for x. Then let's see what we can do step by step using the system of algebra to solve question number 14. Here, the first thing we'll do is add x to both sides. Now, we already know that x is 7, so that goes in on the right side of the equation. Since we have the square root symbol, which I've written as the old code RT for square root, we can get rid of that RT by squaring both sides. Then the expression inside, 2k squared plus 17, equals 7 squared, or 49. Subtract 17 from both sides. 2k squared is 32. Divide by 2 and take the square root. And k is positive or negative 4. But since we have k being greater than 0, the correct answer was C, 4. The last warm-up question to get you in gear for algebra on the SAT is a question that works very well with your powers of estimation. In question number 3, I wrote, the Borealis Lighting Company sells special bulbs that last for many, many years. However, each bulb costs $99 plus a tax of $8.25%. What is the total cost for 6 of these items, rounded to the nearest dime? Well, there is a shortcut so that you two can do the problem faster, and that is to round each bulb to $100 per light bulb. Then, doing 8.25% is much easier since it's 100. Just move the decimal 2 places to the right, meaning that since it's 8.25% of 100, that's $8.25. $8.25. 1% would be $1. 8% would be $8. And 0.25 is $0.25. So we have $8.25. Since we have to add that to the rounded cost of the light bulb, we're saying, oh, those light bulbs are more or less $108.25. And we're going to buy 6 of them. 6 times 108 is 648. Plus 6 quarters is another $1.50 for a total of $649.50. But look at the answer choices. That is answer choice B. Since we rounded up, that's an overestimate for the cost of the light bulbs. So the only logical answer is A. B, C, and D are eliminated because we rounded up and found that $649.50 we know is too much, and the correct answer is A, $643. The next thing we're going to do tonight is just like we do in the SAT class at the tutoring house. We're going to have a warm-up quiz. So when you arrive in class, you too can do 5 warm-up questions of SAT level math. Included are 2 easy level, 2 mid-level, and 1 challenge level problem for you to try. What I have here is the Google Form link here in blue. So if you click on this link, I'll keep it active as long as the video is up, and give you 10 minutes for this warm-up quiz. So starting now, you have 5 practice questions and 10 minutes. I'm going to go to an online timer here on the internet and start one for 10 minutes in just a moment. All right, so please begin if you'd like to participate. For these 5 questions, the link to the form is here, and I'll see you in 10 minutes. Good luck. Okay, just 5 more minutes on tonight's quiz. Number two, 5 more minutes. Ladies and gentlemen, please finish the problem that you're working on and make sure that you have an answer for all 5 questions, the 4 multiple choice and 1 grid in. That's time for SAT quiz number 2 tonight. And go to the Google form and make sure you bubble in on the bottom. And then once you submit your results, the computer will auto grade it and save your work for you. If you did complete it and would like an extra copy sent to your email, just make sure that you email me at JW2542@gmail.com. Next, what we'll do is we'll quickly go over SAT quiz number 2, and I'll try and solve each problem in less than 90 seconds so that you can, too, see a method that works for these problems. Question number 1 reads, the cost of a 4-color pen is $3.75. If the price is increased by 40 cents, how much are 2 pens at the new price? Well, here you can see that I'll just use the annotator. They were $3.75 each. We're going to add 40 cents. So the new price will be 5, put down the 1, that's 11, carry the 1. $4.15 for 2 pens. And we're going to buy 2 of them, so that's another $4.15. And that's a total of $8.30. And as you can see, the correct answer, therefore, is choice B. $8.30 for 2 pens. Question number 2. A map scale on a computer screen says that 5 kilometers equals 80 pixels. How many pixels equal 300 kilometers? Well, here we can set up a proportion with kilometers to the number of computer pixels, and then compare that to another fraction. So here we go. I'll use yellow chalk so that you can see it on the screen. So it says 5 kilometers is 80 pixels, and that must be equivalent to 300 kilometers in the numerator. For the computer screen, that will be X pixels. Looking across, I know that 5 times 6 is 30. So make sure you add a 0, and 60 is the multiplier for the fraction. To keep them equivalent, we have to multiply the denominator by 60 also. That's not that hard because 88 times 6 is 48. And add 2 zeros, 1 0 from 80 and 1 0 from 60. And the correct answer is 4,800, which was choice D. Notice that the wording is sort of means and extremes. So we have X equals number of pixels. That was in the first sentence, it was kilometers to pixels and then pixels to kilometers. Just make sure you set up the fraction with the units oriented numerator and denominator if you are comparing the 2 measurements. Question number 3. What is the solution to the system of equations below? Well, again, let's see if we can use the SAT shortcut that we talked about in other lessons. Here, looks like if we add the equations together, something special happens. Let's see what happens. If we add column-wise, we'll have 3x plus 5x is 8x. And then these cancel. Negative 7y plus 7y, that's the additive inverse. And finally, 12 plus 20 is 32. Divide both sides by 8. And we know that x equals 4. Let's pause for a second. Look at the answer choices. There's only one answer choice where x equals 4. So save your time. That's choice B. Has to be B. None of the other answer choices have x equals 4. If you want to double check and you have the test time, this is a good one to plug in. So checking our answer, we're saying x equals 4. We can see that 4 times 3 is 12. Minus 0 is 12. And 5 times 4 is 20, plus 0 is 20, and true to the system of equations. The solution is x equals 4, y equals 0 for the ordered pair 4, 0. For the challenge questions, I often spend time, an hour or two, making sure that I can present to you a slideshow of them. So I'm proud to present to you the cylindrical pitcher, as well as question number 5, the trains. Question number 4, a cylindrical pitcher, has a radius of 5 and a height of 12. It is filled 4/5 to the top with orange juice. If the pitcher is poured into cups with a radius of 1 and a height 4, each cup filled halfway, how many cups of orange juice can be poured? Well, you can see here in this slide that what I did was I drew the pitcher, but only 4/5 full. So it's not filled all the way to the top. For the volume of a cylinder, it's pi r squared h. But the height isn't 12. It's not filled all the way to the top of height 12, but 4/5 of that. 4 times 12 is 48 over 5 instead. So then when we plug in for pi r squared, we get pi times 5 squared, or 25, times 48 over 5. But lo and behold, 5 divides one of the 5s out, so it's really just 5 times 48, which is the same as 10 times half that 24. So I double this factor, and I multiply that one by a half. So it's the same as 10 times 24, or 240. So it's 240 pi's. For the half cup, again, it's pi r squared. It's a circular base times the height 2. So the amount of orange juice into each cup, like a Dixie cup, would be pi times 1 squared times 2, or 2 pi. So we're taking a supply of 240 pi of orange juice, pouring them into 2 pi each. 240 divided by 2, the pi's get gobbled up, they cancel. And it's exactly 120 cups filled with orange juice halfway. Correct answer was A. Question number 5. Train stations A and B are 800 miles apart. At 9 a.m., train station A leaves station A traveling towards station B at 120 miles an hour. So I drew it as a pink arrow. That's 120 miles of the 800 miles, approximately, after 1 hour. At 10 a.m., train B will leave station B traveling towards A at 152 miles per hour. How many minutes will train A have traveled when the trains pass each other? Well, here you can see here that that first hour was 120 miles. So subtracting that from 800, the distance now between the two trains, A and B, would be 680 miles. But notice that the distance is relative in opposite directions. So A, when it goes another mile, will be another 120, another hour, excuse me. And B, for an hour, will travel 152. So these green hours represent 120 times the number of hours and 152 times the number of hours. So since they're going down the track, they're not going to smash into each other as they're on parallel tracks. But the important thing is the distance between those two sites is 680. So adding those distances together, they will cover 272 miles every hour. They'll be 272 miles closer to each other. Okay, and that equals 680. Dividing by 2, 136h equals 340. Dividing by 2 again, 68h equals 170. And believe it or not, that's exactly 2.5 hours of travel time. So, since train A left the station at 9 a.m., but train B didn't start until 10 a.m., remember that that's not 2.5 hours, but an extra hour for train A. Train A started earlier. So it should add up correctly if we use a rate times distance chart. For train A at a rate of 120 times not 2.5, but an extra hour, remember they started at 9 a.m. That would be times 3.5. 120 times 3 is 360, plus a half of 120 is another 60. That's 420 miles for train A. Train B 152 times 2.5 is exactly 380 miles. And that does add up to 800 miles covered total, the two trains. So after three, at that time, what would that be? At 12:30, the trains could stop on their tracks. The conductors could hop out and shake hands, because at exactly 12:30, the trains would be head to head on different tracks, so they don't smash into each other. But the question was, how many minutes will train A have traveled? 3 hours is 180, plus another half hour is another 30, for a total of 210 minutes for train A. The correct answer was 210. Next, for this mini lesson, we're going to focus on some of the formulas that are given to you for the SAT and discuss what formulas are important, sort of like a crib sheet, for you to get ready as you get organized for your SAT exam. Here we go. As you know, this is the first page of each lesson. Will have a 2 to 4 page mini lesson that starts it. And I wrote, this course is designed to focus on one set of SAT skills each lesson. Most of the important mathematics formulas are included on the first page of each section, the SAT formula sheet. Note that not all the formulas included on the test are provided here. Below the page are more common formulas and mathematics facts that should be known for you to prepare for the SAT. Here we go. So if you look, you're going to have these shapes. They have 2- and 3-dimensional geometry for the reference information. Here you can see a circle with the area and circumference formula, a rectangle in the area, a triangle, a rectangular prism, a cylinder, and then the Pythagorean theorem, followed by the 2 reference triangles, like commonly used in construction over here. There's the special right triangles, the 30, 60, 90 right triangle, as well as the 45, 45, 90 right triangle, and the ratios of sides. The last 2 facts on the reference page that are given to you on the SAT is that the number of degrees in a circle arc is 360 total. And the sum of the measures of degrees in the angles of a triangle is 180 degrees. We'll go into that more, the derivation of Euclidean geometry and the system that we use, still based on the old Babylonian 360-day calendar, in another lesson. However, let's look on my lesson number 2. So I remember when I was in high school, and I went to the Bronx High School of Science here in New York City, and I wanted to get a perfect score on the SAT, math, that is. I had always excelled in math. My mother even got me a math tutor when I was a child. Every Christmas and in December, in the holidays, I'd get math books. And so by the time I was 10, I had a math tutor who was teaching me Calculus 1. This is a true story. I remember my 5th grade teacher was impressed that my mother had hired a private math tutor for me to get so far ahead. And I brought in my calculus textbook and showed her Mrs. Barbatopolo, PS 124 Astor Program for Gifted Children. And I showed her my calculus textbook. And I think it was an Epsilon Delta. It was the Epsilon Delta proofs on that page. And she said, what is this? And I said, oh, that's a line. It's y equals mx plus b. So I didn't say, and I realized afterwards that I didn't explain that he was trying to explain to me Epsilon Delta proofs. I just explained what a slope-intercept form was instead, because that's what I saw on the page. Yeah, I'll show it to you some other time. So anyway, when I got to prepare for the SAT, we didn't have a crib sheet. So I just went to, I guess it was in Algebra 2 or pre-calculus. So I just said, okay, we need to know the quadratic formula. We need to practice as the special factors. And so I'd scribble it down when I sat down for the exam. I wrote down SOHCAHTOA quickly. Pi radians is 180. I wrote down the quadratic formula, the 3 special factors case, SOHCAHTOA, and the law of sines and the law of cosines, which I include here for you. It's really helped me to earn my near perfect score. I got a 790. The other thing that's common knowledge is you should know the systems of measurement from the King's English. So here I have inches and miles and seconds. but also the metric system. So you should know that an inch is 2.54 centimeters. You should know that a mile is 5,280 feet. You should know that a kilometer is 0.62 miles. You should know these facts. And also for capacity, as well as time measurement and weight, which is down below. Pounds is 16 ounces. A pound is 454 grams. It's common knowledge. A kilometer is approximately 2.2 pounds. A ton is 2,000 pounds. And a metric ton is 1,000 kilos. So should be familiar with these. I remember also very good for the SAT on vocabulary. You can just get some index cards and just, like 3x5 index cards and just put the formula on one side and the name of it on the back side. Or some students, they put the formula on one side and then they have an example to work out or an example with the answer on the back. So that's a really good way to study for this exam where they're standardized tests. Okay. So these would be good topics for a set of index cards. Online now they have Quizlet. I was going to make a Quizlet and include it with my class. I just didn't have time because there are only so many hours in the day that you can code and set up schools and do other work. So here's an example of using PEMDAS, which you should know. Please excuse my dear Aunt Sally was the mnemonic device to learn that. Or I went to school in Chinatown. So in 5th grade, I guess it was pandas eat mustard dumplings and applesauce when we started learning pre-algebra, PEMDAS. So then here are 2 examples using PEMDAS. They're included in the lesson in model problems. There's example number 1. And remember that you do parentheses first, then exponents, then multiply and divide together, then add and subtract. Example number 2 is a word problem, and I'll highlight this one because it's worth going over. Here we have the cost of Nimble Thimble taxi is $3 for the first quarter mile and 50 cents for each additional quarter mile. If Mr. Adams takes a cab from this company and the total cost is $26.50, how many miles did he travel? Well, first you have to interpret it. There's no formula given. So the first thing we have 2 different things that are going to cost you. The cost for the first quarter mile, okay, that's a $3 flat cost. That's saying the cab comes over, it's a clean cab, it's got a full tank of gas, right? And it's ready to serve a customer. So that's a $3 pre-charge. And then that's 50 cents, right? Is that right? $3 for the first quarter mile. It's included once you hop in the cab and go. And then every quarter mile after that, you have to be careful, is 50 cents per quarter mile after that. So the way to express that is we could set the first quarter mile right down $3. But then be careful because when you count the number of quarter miles, a full mile will be 4 quarters. But then take away 1 because that's already been paid for by the $3. So that's the total mileage, 4 quarters minus 1 for the cost. We'll get to that in a minute because it's 4 quarter miles. Okay. So then, Q is the number of miles. So 4 times the number of miles will be the number of quarter miles, but then take away 1 because that's $3. Distributing, we have 50 cents times 4Q is $2 for the quarter miles, but then take away 50 cents because it's already been taken care of by the $3 starting fee. Now you have the proper formula equal to $26.50. Add 50 cents to both sides, and it's 27. Subtract $3 and it's 24. Then 2 quarter miles, 2 times the number of miles must be $24 total. This is the new balance. It's now 24 because we added 50 cents and we took away $3. All right, so now it's about 24, and then divided by 2, you get the Q, or the number of miles, is precisely 12. So 12-mile trip. You can check it yourself if you plug in, right? If it's 12, then that would be 3 plus 50 cents times 11.75, right? Because you have to subtract 1 quarter. And that will work out to be $26.50. All right, next one. What's going on here? Oh, that was the last example that I picked to share with you tonight. Well, the time is 7:51. And again, this class is only going to get to 8:30. It's an open class by donation online. You can come and watch it for free if you like. The suggested donation to support this SAT course is $50 per lesson, which you can Venmo at Josh Wiener 10. But here is the link for SAT classwork number 2, and it's all 25 questions that I personally wrote for SAT students getting ready for the exam. And as we do in class, we either do only the even questions or the odd questions as a time saver. So tonight, since it's lesson number 2 and that's an even number, we will do just like in school, we'll do the even questions only. So that will be 12 practice questions. Questions number 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I'll give you guys 20 minutes of practice time. This is a good time for you guys to give it a try. I'm leaving the link on the screen. And again, I'll mute. So I will see you in 20 minutes. If you're watching the recording, you too can fast forward 20 minutes down below, and then we will go over a few select problems from tonight's classwork worksheet. So enjoy my SAT classwork number 2, equations and word problems. Good luck. All right, just 15 more minutes on this practice set. 15 more minutes on these 12 questions for SAT classwork number 2. All right, ladies and gentlemen, just one more minute on tonight's classwork. Even problems only for classwork number 2, equations and word problems. All right, folks. So please take a break from the problem that you're working on. And if you enter your response into the form here for JW2542 SAT course, SAT classwork number 2, basic equations and word problems, should auto grade it for you. And you too can check your answers on these good practice questions for the SAT. As I said, we're only doing the even questions only, and I've prepared a slideshow with the questions. So skipping question 1, which I wrote, which is based on Newton's approximation for the derivative. Let's see, what we're doing. Let's go to question 2. Wait, that's the estimation problem we did in the warm-up. Question 4 is an inequality. No, I don't want to go over that one. I'm going to select the ones we go over. Question 6, Miriam's problem. All right, let's read this one. All right, question number 6 reads, Miriam has to watch documentary films for her job to select the best ones for a film festival. Each month, she receives a batch of films to review, okay? The number she has left to watch at the end of the day can be estimated with the equation F equals 135 minus 6D, where D is the number of days she has worked that week. What is the meaning of 135 in the equation? I think they mean each month. I know because I wrote it. So that's a typo. Each month. So that should say each month. I'll highlight that to edit my own lessons year after year. What is the meaning of 135? Well, think of it this way. If F is the number that she has left to watch, and D is the number of days, this is the number remaining after days of watching documentaries. All right, so she's watching documentary films. Okay, hold on, let me make this a little larger. All right, so minus 6D means that she must watch, if she watches 6 documentaries a day. All right, so what's the 135? That's the starting pile of documentary films that she has to watch. She receives 135 different film files, and she has a whole month to watch them. So at 6 a day, does that make sense? Well, 6 times 30 days in a month, say. 6 times 30 is 180, so that does make sense. So she doesn't have to, she can get, I guess she could take Sundays off then, or Saturday, take weekends off. Right? Because, yeah, she'd need 21, 22, 23, about 24 days out of a month to, if she worked all day or watched 6 per day. Therefore, what's the correct answer? Is it A? She will complete the reviews within 135 days. No. B, she will start each month with 135 documentaries. That's true. C, Miriam views 135 each day. No, that's mathematically impossible. There's 24 hours in a day. D, Miriam chooses 135 days for the festival. No. The correct interpretation is assigning these terms with these meanings. And yes, the correct answer was B. Bravo if you got that one. B was correct, and that reads, Miss Miriam starts each month with 135 documentaries to view. That's her starting pile of documentary film, so to speak. Like if there were books, that'd be 135 books in the library for her to read each month, or in her on her bookshelf, so to speak. Any questions about number 6? All right, let's move on. Question number 8. Based on the table below, which is closest to the average arithmetic mean of the seeds per apple? And they give you a frequency table. So we're going to study these more later on, but this means that there's 2 apples that have 3 seeds each. There were no apples binned that had 4 seeds. They saw these apples, and there were 4 apples that had 5 seeds inside each apple, and so on. There's a frequency table. There was 1 apple with 6. There were 2 apples that had 7 seeds. There were no apples with 8, and then there were 9 apples that had 9 seeds in them. Why, you can make a whole apple nursery for those. All right, so here's apples 1 and 2, apples 3, 4, 5, and 6, apple 7, apple 8, 9, apple 10, 11, and 12. So what I'm trying to show you here is that this is a frequency table. So there's 2 there, just 1 there, 3 there, and that's based on this count of the number of apples like in the bin at the grocery bin. Okay, there's 3 in that bin that had 9 because they were sorted out by the scientist. All right. So now the scientist is saying, well, what's the average? Well, you know your times tables, right? So let's get to some math work. 3 times 2 is 6 seeds plus like 20 plus 6 plus 14. Just do it whatever way is easier. Here's one way of doing it. 3 9s is like 27. Then these go together. That's 20 plus 20 is 40 plus 6 plus 27. Then 6 and 27 is 33 plus 40 is 73 seeds scientists found, and there were 12 apples, and that's 6 and 1, 12, which is closest to the whole number 6. So on average, there were about 6 seeds per apple for question number 8. Question number 10, what is the solution to the second degree equation? And it reads, x squared minus 6x plus 9. Well, we're going to plug in the choices. Here, work backwards. It's got to be 1, 2, or 5, because those are the only answer choices. So let's get to work. We're going to plug into the formula for x equals 1, for x equals 2, and also for x equals 5. You get what I'm saying? So 1 squared is 1 minus 6 plus 9. We plug in 2, 2 squared is 4 minus, well, 2 is 12 plus 9. If we do 5, then that's 25 minus 30 plus 9. All right, so then you just have to do the arithmetic now, just with the pluses and minuses. Well, 1 minus 6 is minus 5, plus 9 is 4. So we have a winner. X is 1. 4 minus 12 is minus 8, plus 9 is 1. So that's not a match. And negative 25 minus 30 is negative 5, plus 9, again, is 4. So 2 of them are true, which I'll highlight in green. You have 2 winners here. X equals 1 works. You can see we did the math here, and it equals 4. And x equals 5 works. So winner, winner, chicken dinner. 4 and 4. Correct answer is both 1 and 5 are the legit solutions. And 2 is incorrect. So the correct answer is a D. 1 and 5 are solutions for this second degree equation. Second degree meaning as highest exponent there is 2. This polynomial. Any questions on number 10? All right, we do not have much time left. This is a 90-minute class, and you guys have other things to do. You have a life. Let's go to question number 12. Maybe. Let's see. What else is good? 14. So 18. Logs 20. You know, I read an article. They're going to take complex numbers off the basic SAT, which is not a good step forward for STEM workers, if you ask me. Everyone should know complex numbers. But I do. They're dumbing it down again. But anyway, let's go. Roxy earned 63, 81, 75, an 86, and a 90 on her first 5 exams. 1, 2, 3, 4, 5. What must she earn on the next 3 exams to earn an average of 85? We don't know what she's going to get, but she has to do that 3 times. And then that'll be 5. That'll be 8 total. Here, let me write this out for you. That'll be 3. Sorry, something's wrong on the pen with these pixels on the screen. Or these pixels not good. Plus 3 exams. So we're representing that as 3x, sort of the average over the next 3. But these are the points that she's earned so far. So Roxy's 5 exam scores. In her math class, she's earned these so far. So they're in the records. But she wants to average an 85. So what are we going to do for Miss Roxy? So that'll equal 85. Well, that's over 8 exams total, right? We're representing the other 3 as 3 times some unknown. Well, 8 times 85, we can multiply both sides by 8. Yeah, why is it skipping these pixels? We can multiply both sides by 8. So, but we should add these together and see how many points she's earned so far. Well, the way I'll do that is I'll add the ones. 11, 12, 13, 14, 15 ends in a 5. Carry the 1. Now it's 7 plus 8 is 15, plus another 15 is 39. So 395 plus 3x equals 8 times 85. Well, using my Russian peasant method, which is we're going to double one side. You could double or triple one factor and then half the other one. I'll divide this by 2, make this a 4. And I'll double this. 85 plus 85 is 170. Aha. Still too difficult for you if you can't do 4 times 17? Do the same thing. It's the same as 2 times 340. So her points goal is really 680 points total. But she's already earned 395. So we'll subtract that from the points total. Well, I'll subtract 400. That'll be 280, but then put 5 back, so 285 equals 3x. Then dividing by 3. All right, I subtracted, and so now it's just 3x. Dividing by 3, that's 95. The correct answer was D. D was correct, 95. Another way to do this, I know that we're running out of time, so I'll do this quickly. Remember, 95 is the correct answer, but I'm going to erase this work down here. Is say we want to get an 85 average. And this is one of these statistics shortcuts. If you're taking AP statistics and you were my student, you saw me do this all the time to check work really fast. So let's say Roxy wants to get an 85 on average. That means she'll have an 85 for test 1, an 85 for test 2, an 85 for test 3, an 85 for test 4, right? But she's going to repeat that. So she's going to, it's like she has 8 85s, right? So what we'll do is we'll tag each one relative to 85. 63 is 73, 83. She's 22 points less. She gets an 81, that's 4 points less. If she gets a 75, that's 10 points less. If she gets an 86, that's a +1 on exam number 4. And if she got a 90, that's a +1. 5. You get what I'm saying? That's assigning each of these completed exams either above the mean or below the mean. That's her goal. 75 is 10 points less. 86, she's at 1 point above the average she wants, and so on. All right, now she has 3 exams to go. But how far is she behind the average? We'll add the positives and negatives. So here we go. So that's minus 36 points below total. But on the positive side, for the test 4 and 5, she's at a +6. So that means that she's really 30 points below. So if we gave a +10 to each of those last 3, that's divided by 3, she's got to step it up. She's got to be 10 points above on test number 6, 7, and 8. Aha. And she'll have an average of 85. So what is 85 plus 10? That's the test average goal of 95. It really works. So there's another way of doing the arithmetic mean, is thinking, oh yeah, that would mean that if she was like a machine that always got 85s on every assessment, you should have 885, so you can just do it relative below or above, okay? Below or above that average of 85. Okay. All right, something you'll explore more if you're interested in AP statistics and math and science in college. All right, it's time to stop for tonight. It's almost 8:30. Again, thank you for joining me. And remember that I do have the links here for free online, which I'll leave up for the next minute. SAT lesson number 2. Here's the Google form link for the quiz, classwork, and homework of my course. The next class will be next Tuesday, 7 o'clock to 8:30. I will post this online on YouTube. Please feel free to donate. I'm recommending $50 per lesson, which is competitive and a lot less than my actual course at the tutoring house. This is, again, I lived by donation for many, many years with a successful juggling and piano show. And I'm offering this again by donation, so pay what you like. But I did take that money and put it to good use and completed my college education. Going back here, you can read more about me and my success as a tutor with middle school and high school students, with the Catholic School Tax Test, the Cooperative Test, the High School Placement Test, as well as the SAT, ACT, PSAT, SHSAT, AP exams in math and science, as well as the GRE for college students. My students have been accepted into high schools of their choice, as well as college programs and graduate school and medical school programs. So thank you so much. You can check me out at my Wix website. I still do serve privately and also work aligned with tutoring houses here in Brooklyn as a math specialist tutor and math and science. Officially, I have taught in public and private schools, as well as Catholic schools and mathematics for middle and high school. So I have been doing this for quite a while. So thank you so much for your support. The other thing is, as we sign off, again, I'll leave this slide on. Hopefully I will see you next Tuesday. I will post this on YouTube with the links. And enjoy your studying as you get ready for your SAT exam. You'll find that this is a very good way of getting organized and checking your skills, making sure that you can earn those 10-point questions each, on average about 10 points, as you get ready for a standardized test. So again, thank you so much. And thank you for your support. I wouldn't be a teacher without the support of people like you. And again, I offer this as an open share service to the community. All right, good night, and have a pleasant tomorrow. I will see you next week, perhaps September 26th, 2023. Thank you, and this is Josh signing off from this Zoom meeting, and I will post this on YouTube later. Thank you so much for your kindness and support. Take care, and bye-bye.